So we had stopped at cosine at 270 degrees yesterday. So this specific problem was only asking for the cosine of 270, which we said was 0. Now, the next one is asking for the cosecant of pi over 2. So remember we were talking about the quadrantal angles, and we said when an angle lands on one of the axes, then we just come up with a coordinate point like 1, 0, negative 1, 0, 0, 1, and we use one of those. So here we have cosecant of pi over 2. All right, so let's talk about where the terminal side for pi over 2 lands. Is it left, right, top, bottom? Top. And we come up with a sample point there. So here at that point, x will be 0 and y could be a 1. And in every single one of these, this is the length of r, radius. And how big is that from 0 to that point? That's 1 unit.
How do you know it's 0, 1?
I choose it for it to be 0, 1. It could be 0, 3, 0, 5.
How do you know that
It's at the top because it's pi over 2, right? And do you remember if it's pi from here to here, then half a pi would just be that part, right? Okay, so once we have that, remember what we were saying yesterday, this is x and this is y. Now, cosecant is like the sine. Sine is y over r, so this will be r over y right here, okay? So cosecant is r over y, which is 1 over 1, 1. And just for fun, can we come up with some of the other ones? So what would sine of pi over 2 be? Sine of pi over 2, that's y over r, so just 1. Cosine of pi over 2 would be x over r, so it would be how much? Cosine pi over 2? 0. Tangent of pi over 2 would be y over x, 1 over 0, which is undefined. And what would secant of pi over 2 be then? Secant of pi over 2?
It would be r1, right?
Well, secant is the reciprocal of the cosine, right? So it would be undefined. All right. All right, so let's talk about negative 90 degrees. Where is negative 90 degrees? Top, down, left, right? The bottom, here. All right, what coordinate point are we going to use for that one?
0, negative 1.
0, negative 1, thank you. So tell me then how much the cotangent is at that point. It would be what over what?
Y over x. X over y.
X over y. So 0 over negative 1, which is just 0. Okay? So for each one of these quadrantal angles, we're going to use the coordinate point. Okay? All right, let's talk about reference angle. A reference angle is an acute angle, and it lies between the terminal side and the nearest x-axis. Okay? So the terminal side and the nearest x-axis. Why do we like the reference angle? We can use it to evaluate trig functions of any old angle. And the symbol for reference angle is theta prime. So it's just like a theta with an accent mark. We call it theta prime. So let's go back to what the reference angle was. It's the angle between the terminal side and the nearest x-axis. So we know that any angle can lie in one of the 4 quadrants, right? Okay. So suppose you have an angle in the first quadrant. Like, for example, suppose you have an angle that's 70 degrees here. Okay? The reference angle is between the terminal side and the nearest x-axis. So from the terminal side, I could either go down to the x-axis or to the left towards the x-axis. Right, down is the closest way to get to the x-axis, so that is the reference angle. In this case, it's just the same as the angle before, 70 degrees. Okay, that's the boring case. What if you have an angle that's, let's say, 120 degrees here? It would be 60, right? So this is the angle. The reference angle is between the terminal side and the nearest x-axis. Again, I could either go left to the x-axis or right. I always take the closer path. I go left here. So now I think to myself, all right, this whole thing, right, had I gone all the way to the axis, that would have been 180 degrees. But I stopped at 120. How much is the balance? 60 degrees. So it's something you sort of have to reason out. All right? So theta prime is 60 degrees. All right? What if we have an angle of, let's say, 210 degrees? Here. Okay? Reference angle is between the terminal side and the nearest x-axis. So how much? All this is 180. How much more in the red did I have to go to make it 210? 30. So the reference angle is 30. Okay. And then here, let's say we have an angle of 300 degrees. 300 degrees is all the way there. Reference angle, terminal side to the nearest x-axis. So again, I think to myself, all right, had I made a full circle, it would have been 360. But I stopped short. How much short? From 300 to 360, 60 degrees. All right, now every single book has this. They give you this, right? And they say in each quadrant you have to blah, blah, blah. Do we really need that? I hate it. So every year I tell my students, you know what? If you see that in any book, just cross it out. Cross it out, because why would you want to memorize something that you're going to forget? We can just reason it out, because we could all do that. Okay? So here, let's find some reference angle. First, we have 135 degrees. Let's sketch it. That's 135 degrees. Reference angle is here. How much is that? So if I had gone all the way down here, it would have been 180. So it's 45 degrees. Okay. What about negative 240? Let's draw that. Negative 180, negative 240 is right there. Okay. From here to here, it's 180. How much more did I go to make it 240? 60 more. So theta prime is 60. Now, I'm going to tell you a little secret for the radian. Don't tell anybody though. Okay? Look at 5 pi over 4. Is it simplified completely? You can't reduce anymore, right? It's reduced. So, the reference angle is just pi over that. Yes. So it's so much easier.
Always?
Always. As long as it's reduced. Up here, right guys? As long as it's reduced. So for example, if you have 21 pi over 3, that doesn't work because you can reduce that to 7 pi and that doesn't work. All right? If you have, let's say, 22 pi over 12, that doesn't work.
Once you reduce it,
Once you reduce
you
it,
still have to find the You would still have to find that reference angle.
Once you reduce it, then it's just pi over the denominator.
Okay.
Okay, let's draw 5 pi over 4. 5 pi over 4. Good, 1 and 1/4 pi. So I start here. I go 1 pi, and then another 1/4 of a pi is right there. Okay. All right, 11 pi over 6. Let's draw that. This is 1 and 5/6 of a pi. So which quadrant are we going to land in? 4? Yes? Do we know why? Are we sure we know why? Yes? Okay. What's the reference angle? Pi over 6. Easy as pie. Get it? Haha. All right. Okay. Why do we care? Because with this, I could give you any old angle. Oh, I don't know, 21 pi over 4. And you can find sine of 21 pi over 4 with the information that you have. You just need one more piece of information. So, to find the value of the trig function of any angle, here's what we do. Okay, I can highlight that. We sketch the angle and find the reference angle. We just learned how to do that. We're experts at that. Check. Evaluate the value for theta prime. So once we have that the reference angle is pi over 6, then we just find like sine of pi over 6. We can do that. We know how to do that. We learned it before. Then determine the SIGN sign. And this is where I hate that SIGN and like sine sound the same, sine and sine. But the last part is we have to find whether it's positive or negative. And we use that, what we use for that is this statement: all students take calculus. It does not have to be a true statement. It just has to work for our purposes, okay? All students take calculus. The way it works is this. We go, remember how it's all counterclockwise? So it's all students take calculus. Okay? All students take calculus. Now, what these symbols stand for is, it says in each quadrant, okay, it says in each quadrant what is positive. So for A, all functions are positive over there. What do you think S stands for? Sine is positive in that quadrant. Tangent is positive here, and cosine is positive here. That means if an angle is in quadrant 2 and you want the sine of the angle, it'll be positive. If you want cosine or tangent, negative. In quadrant 4, is sine positive or negative? Negative. Now, when we have sine, tangent, and cosine, that also counts for their buddies. So sine and cosecant, tangent and cotangent, cosine and secant. All right, but we remember all students take calculus. Okay, so let's apply all this. Let's apply it to this one. Tangent of 5 pi over 3. We're going to go with number 1 first. Sketch the angle and find the reference angle. All right, so 5 pi over 3 is 1 and 2/3 pi. So I draw 1, and how much? Okay, so 1 pi. And how much is 2/3? Am I going to go in quadrant 3 or 4? 4. 2/3 is more than half. All right, so here. What I care about here is the quadrant in which it lands. It landed in quadrant 4. That's the reason of drawing it. If in your mind you know that 5 pi over 3 will land in quadrant 4, you really don't have to sketch it. I'm not going to grade you on the sketching part. You know what I mean? Okay. Now, what's the reference angle? Pi over 3. Okay, so we did part number 1. Number 2 says evaluate the value of the trig function for theta prime. So what we're going to do is tangent of pi over 3. Okay, remember how we were doing tangent of pi over 3 way back when? Where was that? Here? We did it a long time ago. So how do we do tangent of pi over 3? What's pi over 3? Is that the 30-degree or the 60-degree angle? Pi over 3 is the bigger angle. It's like the 60-degree angle. Okay? Okay, so let's talk about pi over 3 and pi over 6, right? Let's talk about how much is that in degrees. How much was pi in degrees? 180. Divided by 3, how much would that be in degrees? 60 degrees. Or if you want to convert it, right? That's 60 degrees, pi over 3. Okay? So now look. Here is 60 degrees, 30 degrees. Do you remember how to set up the sides here? Remember we said the 30-degree always gets a 1 and the 60 root 3 and a 2. So what would the tangent of the 60-degree be here? It's opposite over adjacent, root 3 over 1. So we did that. That was number 2. And then number 3, determine the SIGN sign. In this quadrant, is tangent positive or negative? So it's all students take calculus. Tangent is negative. So this would be negative root 3 for the answer. I know it's a lot. Let's do one more. Look, we have sine of 150. First, let's draw 150. How much would the reference angle be? 30. Okay, so next, let's find the sine of 30 degrees. If I use the same triangle here, sine of 30 is opposite over hypotenuse, 1/2. Okay. In that quadrant, is sine positive or negative? Positive, so it would just be positive 1/2. Okay? All right. So let's stop here for this.